tomorrow will be better. An electromagnetic wave source was found to produce 3,300 oscillations every minute. Find the period of oscillation and thus the wavelength. Follow me, dear friends. Solution. Just to remind us here that when reading this kind of problems, we have to read in between the lines because there are lots of information hidden between the lines. First of which here is electromagnetic. We should know that once we are dealing with an electromagnetic wave source, then the speed of that wave is going to be 3 times 10 to the 8 meters per second. That's the first information to extract by reading between the lines. The second one here is something that looks like the frequency, but it is not actually it. Look at it carefully here, dear friends. It says 3,300 oscillations every minute. But by definition, dear friends, the frequency of a wave is the number of computed oscillations every second, dear friends, not every minute. Every second, okay? So we will rearrange this to look like what is important, and that's the frequency. So frequency is number of oscillations per minute, no, per seconds and not per minute. So how do we transform this to be our frequency? We will divide the number of oscillations, which is 3,300, by 1 minute. Dear friends, what's 1 minute in terms of seconds? 60 seconds. Very correct. So if you correctly punch in your calculator, you will have that this is going to give you 55.5. What's the SI unit of frequency? It is the hertz. Very correct. Hertz. Okay. Now the question says find the period of oscillation, dear friends. This isn't the period yet, but this can enable us to get the period. How? Remember the formula that says period is the reciprocal of frequency, dear friends. Never forget this formula. Always have them offhand. So period is the reciprocal of frequency. If you apply this correctly, we will have that the period here will be equal to 55. 1 divided by 55.5. And once more, if you correctly punch this, we will have 0.018 seconds because period is a time. By definition, period is the time taken for one complete oscillation, dear friends. We are almost done, but we aren't done yet. Now it says find the wavelength. Once more, we have to recall a formula, that of wave speed, which says wave speed is equal to lambda f. In this formula, lambda is the wavelength which we are looking for, and then f is the frequency. All right. This could otherwise be written as this all over t, where t is the period. It's all up to you. So according to this, it means we will say this implies that lambda, which we are looking for, is the wave speed divided by the frequency. All right, so we have here to the 8 divided by 55.5. Once more, if you correctly punch your calculator, we should have 5.45 more or less times 10 to the 6 meters, because lambda is the wavelength and wavelength has as SI unit the meter. Join me, let's make tomorrow better.